everybody. Again, my name's Esther, and I am a staff software engineer on the targeting team here at Quantcast. And today I'm going to talk to you about how we use machine learning here at Quantcast to specifically in the context of our ad targeting product. This will not be a lesson in machine learning, and I'm sorry if you were expecting that. So what do we use machine learning for? We use it to reach a specific audience. So each of our clients is running a display advertising campaign, and they all have a specific goal in mind. So that goal can be anything from raising brand awareness or driving certain actions like clicks or purchasing products or anything like that, right? So we use machine learning to help our clients target the right people at the right time in order to accomplish that goal. So for you to understand what it actually means for us to target people, you need to understand what real-time bidding is. So real-time bidding, or RTB, is a mechanism to deliver ads by auction, individual, like on an impression-by-impression basis. So impression meaning like an ad view. So with real-time bidding, we can target people at an individual level, and we can also buy impressions at an individual level. So hopefully this illustration I'm going to go through is going to clarify what that actually means. So let's say you're this little gray stick figure, and you go to a website. A lot of things actually happen before you see an ad on a website. And the first thing that happens is that a request is fired to an inventory supplier. And what this inventory supplier is there are several inventory suppliers out there. Some examples are like Google, AppNexus, PubMatic. But what happens there is basically a milliseconds long auction where the inventory supplier asks all of their bidding partners, how much are you willing to pay to show this person an ad? So what happens is they would send out bid requests to all their bidding partners requesting a bid. And Quantcast is one of those people doing the bidding. So this is a blind auction, meaning that none of the participants know what the other people are bidding, but everybody sends back their bids, and just like any other auction, the highest bid wins. And then the inventory supplier will then choose that ad, and that's the ad that you end up seeing. And a lot of people are surprised that this happens because it happens in literally 10 milliseconds, so you probably have no idea. So how do we actually use machine learning to do this well, right? The part that machine learning has in this is that we need machine learning to understand how valuable each one of these bid opportunities are. So we use machine learning to basically come up with an optimal price. So what this means is that we train machine learning models and we use them in real time to understand how we should price each bid. So what does this model training actually look like, and what are these models trained off of? Like I said before, all of our clients have a specific goal in mind with their advertising campaigns. And usually, in the most common case, they're trying to drive a certain action, which a lot of times it was represented by a site visit or like a certain page. So for example, like a shoe supplier or shoe company might want to drive shoe purchases, in which case they would choose like the thank you page or the shopping cart, which indicates that someone actually bought the shoe or expressed interest in a shoe. Or an insurance company might choose the request a quote page. And in any case, the client will tag the page, and in that way, we can then label our data. So our data, like Dorothy was saying, comes from our measure network, which is made up of more than 100 million sites. And from that, we have this really rich data set of user behavior and really interesting things that we can actually then label as converters and non-converters, or the baseline. And then this is very simplified, but then we run a supervised learning algorithm and we produce a model. And that model will then tell us, what does someone who converts actually look like? This data that we, like Dorothy said, we process about 30 petabytes of data a day. a lot of that is because of model training. We built infrastructure to train thousands of models a day, process, again, lots of petabytes of data, and that way we have up-to-date models for all of our clients at all times. So now I'm going to go over an example of what a model actually looks like. We train a lot of different models, but this is just like a very old example with a very curated set of features. But basically, this is an old model that we trained for an online dating service who was a client of ours. So you can see that the green coefficients correspond to features that mean that you're more likely to be interested in an online dating service, and red ones mean you're less likely to. So you can see that a lot of these are actually very intuitive and make a lot of sense. So for example, obviously, if you're looking for online dating, you're probably gonna register for online dating. And if you're looking for baby care, you're probably too sleep deprived or too busy to care about dating. But some of them are a little less intuitive, right? Like fantasy sports. Does that mean you're single? I don't know. And if you like books, maybe you would rather meet people in different ways. I don't know. But the point is that thank you. The point is that even if you're an expert in your product or your market, machine learning is going to pick up on all these signals that no one would normally be able to find. And normally models have millions of features. This is just like a very curated set. So how do we use this model in real-time bidding? So when we get this bid request from the inventory supplier, we have to retrieve the user data that we have for this particular bid request, featureize it, and then basically score it against the model. And from that, we can calculate basically a number that tells us how likely is it that this person is going to be a converter or someone who's of interest to our client. And then based on that, we can calculate a bid. And I realize that's very simplified, but on very, very simplified terms, the bid is calculated from both the score and also several different control signals that we have, which indicate how much budget the client needs to spend and things like that. But very simply, if you're more valuable, we'll bid higher. And also, this entire process, again, happens in less than 10 milliseconds. And we do this for about 1 million bid requests per second. So that's kind of like an overview of what happens right now. So what are we working on in general, or what are we continuing to work on? Scalability, obviously, always an issue for any engineer. How do we make sure that we can do this for more clients, more data, more complex models, or just more bids? And then also, ad tech is a very dynamic industry. It's relatively young. Things that our clients care about from one year might be different the next. And because of that, we have to adapt quickly. So we have to always be updating our models to be optimizing for the things that our clients care about. And even besides that, if our clients care about multiple things, how do we make it so that we can optimize for different goals, balance those against all the constraints that we have as well? And that's it. I'm gonna